All right, so I'm going to go over some of the questions of the different kinds on this video, and the ones I circled are the ones I'm going to go through. So I'm going to go through the $600 and $800 question for the slopes, all of the interpreting slopes worksheet. Is it direct variation 2, 4, and 600? Direct variation 800. This one is very similar and starts out with some of the ways that we do for this 1,000 one. So that's why I chose to do the 800 because it includes that 1,000, but also a little bit more. And then I'll do one graphing question for you. All right, so if none of the videos on here are, or if none of the questions are here, the ones that you're looking for, try to apply what we're doing in these questions to the ones that you are looking for help for, or you can reach out. All right, so for this question, number 600, you're asked to find the constant proportionality, which we know is just another way of saying slope. So we're trying to find the slope of this line. And the ways that we learn that we can do this is we can find where the line passes through the corner of these boxes, because that represents that's guaranteed to be whole numbers for both our x and y value. And then we just need to go ahead and count our change in y over our change in x. So you see we're going up 1 and we're going over 1. So our change in y and our change in x is both equal to 1 as far as what we're going up. However, we need to be mindful of what our x and y coordinates are actually changing. So as we move 1 up 1 for our y value, it's not actually a change in 1, but our change in y is actually equal to 10, because as we move up one box, we're changing 10 in our y value. And our change in x, as we move 1 over, we're changing by 2. So our change in x is actually 2. So one of the things I was telling you is be mindful of your axes. So make sure that you are paying attention to that. So our change in y over change in x is equal to 10 over 2, which then our constant proportionality, or our slope, is equal to 5. All right, so for this one, I just want to practice going over the formula with you. We have m is equal to y2 minus y1 over x2 minus x1. And we have the 2 points of 1, 5, and 4, and 11. So I'm going to go ahead and denote this as my x2, y2, and this is my x1, y1. Remember, it really doesn't matter which one you choose. I'm choosing this one to be my x2, y2 because I see that they're both larger than my x and y in the other order pair. So I just want to make sure that my numbers remain positive. So my x1 is equal to 1, my y1 is equal to 5, my x2 is equal to 4, and my y2 is equal to 11. And now I can just go ahead and plug it into this formula that my slope is equal to y2 minus y1, so 11 minus 5, over x2 minus x1, which is 4 minus 1. So this is now equal to 6 over 3, or 2. So my slope is equal to 2. All right, so for the entire interpreting section part, I'm just going to go through this kind of quickly. It says Hannah and Nancy visits a farmer's market to buy pineapples. The graph below represents the number of pineapples and their corresponding costs. Read the graph and answer the questions that follow. So find the unit rate represented on the graph. So we know that's another way of talking about our slope. So we're going to find our slope for this first problem. Once again, we want to find where it crosses in the corner twice. And we see our change in y is 1. However, our y value as we move up on our axis is actually 2. So our change in y is equal to 2. And our change in x, we're moving over 1, and we are counting by 1. So our change in x is equal to 1. So our change in y over change in x is equal to 2 over 1, or 2. So the unit rate is, we would say, we can say 2 pineapples for every, $2 for every 1 pineapple. What does point A represent on the graph? Well, point A is telling us that we are paying $14 for 7 pineapples. So it's an order pair of 7 comma 14. And since this order pair or the relationship is telling us how much we're paying, we can say that we're paying $14 for 7 pineapples. How many pineapples can Nancy buy for $8? Well, I would want to then look to see, well, here's the cost for $8. And I'm going to find out, as we talked about, the graph represents all the answers or order pairs of solutions. So here I find where it reaches my graph at 8, and then I look down and say, okay, well, how many pineapples can I buy for that? And we can say 4 pineapples. Now you could solve this a few different other ways, but I wanted to practice us seeing using the graph to solve. What is the cost for 2 pineapples? Well, here's the number of pineapples once again. We can then just go ahead and find where 2 is on our x-axis and see, okay, well, what is our y value for 2? And that will then be $4. So you see we're using the graph to generate these. How much will Hannah need to buy for 5 pineapples? So once again, we go to 5 here, and we can solve this a few different ways. I go to where my graph is, and I see here it's where it meets my graph. So my cost for 5 pineapples is $10. Or since I knew it's $2 for every 1 pineapple, I could have just said 5 times 2 to get to this 10, and I also could have said 2 times 2 to get to this 4 as well. So we could have read the graph, or we could have used our answer from A to generate those answers. All right, so for this problem, we have 3y is equal to 9x. And now when we're trying to find out, when we're given an equation, if this is direct variation, our goal is, can we rewrite it as y is equal to kx? Or can we isolate our y all by itself and have it rewritten where it's just some constant multiplied to our variable x with nothing else being added or subtracted? So our goal is then to see, well, how do I get y all by itself? Well, it's 3 times y. To get rid of multiplication, we divide. So I divide each side by 3. Now I get y is equal to 9 divided by 3 is 3. So we get y is equal to kx. You see it can be written, y is equal to 3x. It can be written in the form of y is equal to kx. So yes, this is a direct variation. If I could not write it in the form of y is equal to kx, then it would not be a direct variation. All right, so for question number 4, this 401, when we're given a graph, there's 2 things. 1, does it form a line? And 2, does it pass through the origin? And as long as if it does both of these, then we know that this is a direct variation. And here I see it passes through my origin because it goes to the part where the 2 axes meet, our point 0, 0, and it does form a straight line. So this checks off both of them. So yes, this is a direct variation. Because it forms a line and passes through the origin. All right, now on to the next one. All right, so for this problem, we're given 5x plus 6y is equal to 30. Once again, our goal is to see, can we rewrite it as y is equal to kx? So if I want to start isolating my y, I see that this 5x is being added to it. Even though it doesn't say plus 5x, it's a positive number, so it's being added. So I would need to subtract this 5x to move it to both sides. So now I get 6y is equal to negative 5x plus 30. And then from here, to isolate that y, we need to divide by 6. Now the thing is, when we divide this right-hand side by 6, it actually creates 2 different fractions. We need to divide and separate them and think about negative 5 over 6x plus 30 over 6. And then we can reduce and say, well, this negative 5 over 6 can't change with that, but this 30 over 6 reduces to 5. So you see, we have a plus 5 at the end here, and when we're doing our direct variation, it needs to be just a number being multiplied to a variable x with nothing else being added or subtracted. So this is no, it is not a direct variation. And as we talked about in class, this is actually telling us our y-intercept. So it's actually telling us that when we cross the y-axis, it'll be up here at that positive 5. And our graph will look something like this. So it wouldn't go through the origin. All right, so for this question, we're first asked to determine if it is a direct variation. So since we're given a table, there's a few different ways we can do this. But I'm just going to go ahead and actually, I need to change this axis real quick. All right, so for this, we first need to determine if it's a direct variation. And one of the ways we can do that is by plotting these points and seeing, does it form a line? And does it pass through the origin? There's different ways that we can do this as well. I'm just going to show you this one first, or show you this one only. So I see that I have a total of 12 tick marks, or 12 tick marks for me to count my numbers. So I'm just going to go ahead and count by ones with my x values, but I'm going to skip that one every time, so this way I can just not have it look so messy. And also I know that since I'm counting by 2 there, 4 there, that this has to be 1, 3, and so on. And then the other one, I'm going to go ahead and count by 8. So 8, 16. I'm going to fill the rest in. All right, and then once I figured out what I need to do for my x and y axis, I'm going to go ahead and plot these points. So we have 2 and 16, so that'll be here. We have 32 and we have 4, so that'll be here. We have 48 and we have 6, and we have 64 and we have 8. So I can clearly see that these form a line for these points, but I also need to check, will it go through the origin? So I see that my change in y is going down 2, my change in x is going over 2. So then I need to continue the same pattern to see, well, down 2 and over 2. So it would generate another point that would continue to go to that origin. So yes, it forms a line, and yes, it passes through the origin. And now we just got to go ahead to figure out our direct variation. It's y is equal to kx. We need to figure out what our k is equal to. So for our k, we can just go ahead and count. Well, we already know we're moving down 2 and over 2 for our coordinates every time. And I can see, okay, well, I'm changing by 8 each time. So when I go down 2, or let's just say we're counting over 2 and up 2 just to keep them positive. So that means my change in y is equal to 16. And when I'm going over 2, my change in x is equal to 2. So I'm doing 16 over 2, which is equal to 8. So my k is equal to 8. So my equation would be y is equal to 8x. If you were figuring out this formed a line by creating ratios, or you can always just see like 8 times what gives me 64. Well, I know it's going to be times 8. So you can just check, does 6 times 8 give me 48? Does 4 times 32 give me 8 times? Does 4 times 8 give me 32? And does 2 times 8 give me 16? And since they all worked, then you knew it formed a straight line. And then the last thing you would just have to show is, well, if x is 0, 0 does 0 times 8 also give me 0? And just so that way you can check it goes to the origin. All right, then there's just one more question that we're going to be doing, and that is it for this video. All right, so for the last one, remember, this is just extra credit. We have the equation y is equal to 1/2 x plus 3, and we're asked to graph this. Remember, this is our slope-intercept form, which is y is equal to mx plus b. So our m is our slope, and that's what's being multiplied, what's being multiplied to our variable x, so it's 1 over 2. And our b is the numbers being added or subtracted, so it's 3. Remember, the b gives us our starting point. It gives us an actual location, so it gives us an ordered pair that we know crosses our y-axis at 0, 3, so I can plot that point there. And then remember, our slope is our change in y over change in x, and it's giving us directions. It's saying from this point, we can go up 1 and over 2 to get to our next point on this graph. So up 1, over 2. So there's another point that we have. Then we can go up 1, over 2, and there's another point that we have. And once we generate those 3 points, you would use a straight edge or a ruler to go ahead and connect these points. I can't really use one on this tablet, so I'm just going to try and draw it as best as I can. And that is what our graph would look like. All right, and that is it for this video.